Good morning, afternoon, wherever you're watching this. My name is unknown to anyone who does not know me, but it does not matter who I am, it matters what I talk about. Okay, so today I want to talk about metallic and non-metallic oxides. Before we start, we have to identify what an oxide is. An oxide is basically when an element reacts with oxygen, and that's it. Now, there are there are two main types of elements, metallic elements and non-metallic elements. Let's begin with metallic elements. Metallic oxide is where a metal, let's say this is a metal, reacts with an oxygen atom to create something like this. Now, there are multiple versions of this based on the number of oxygen reacted. For example, it could become uh, metal, monoxide, metal, dioxide, there are two oxygens, and so on, so on, so on. Now, when metals oxide, they often have similar characteristics. What are those similar characteristics? Well, first of all, metals will have low solubility, or metals that are oxide will always have low solubility and a pH of 7 plus. A pH of 7 plus, which is basically an alkaline solution. I hope I am right. So, what are the main characteristics of metallic oxides? Metallic oxides are ionic compounds by the okay. Key characteristics of metallic oxides conclude that they are ionic compounds, as electrons are transferred from the metal to the oxygen. For one, they are ionic compounds, as metals are transferred from the as electron goes from metal to oxygen. That is the most important part, which gives its key characteristics. In addition, they are generally solid at room temperature. At room temperature, they are generally solid, but when heated to a certain temperature, they will often reach a molten state or melted state. But that makes they have high boiling point and melting point because they're metals. Metals, except for mercury and other exams, have high BP and MP, melting and boiling point. And most importantly, metallic oxides are basic solutions due to the pH solution being so high. Because they have a 7 plus pH solution, it means they are basic solution. So when they react with acid, they form as salt and water in a neutralization reaction. So basically, metallic oxides are basic solutions that can react with certain acids to form salts and water. This can be seen in the reaction of in the formation of NaCl or KCl, table salt. Table salt is KCl, not NaCl. NaCl is a fraud. We think it's table salt. It's not. It's KCl. KCl is the real table salt. So we have Ko, which is potassium oxide, reacts with acid HCl to form KCl salt and H2O. This is a neutralization reaction in which KO is formed by K plus and O minus. I am incorrect. I know. I don't care. To form potassium oxide. This is the basis of neutralization reaction. We got a metallic oxide reacting with an acid, forming a salt and water as a substrate as an excess. Let's continue. So, we discussed this, let's discuss more. Some metals are aphoteric, some metallic oxides are orthoteric, meaning they react with both acids and oxidases. We have metallic oxides that are aphoteric, meaning they react with both acids and bases. Like that matters. Due to their ionic nature, metallic oxides are poor conductors because their electron pairs don't because metallic oxides are often why not? Because of electricity in the solid state. Oh yeah, they are poor conductors of electricity in their solid state, but can conduct electricity when in a liquid or molten state. Oh yeah, yeah. So this is because when they're in a solid stature, They're because as a particle because you see it's because of the particles. Usually we can transport electricity because of particles. When they're in liquid or gas, the particles are more relaxed and are less moving, producing effective nuclear charge. Though when a metal is solid, its particles are not relaxed. They're relaxed. They're straight, meaning there's a high amount of effective nuclear charge, making it difficult for electricity to conduct. Now let's come to the non-metallic oxides. Non-metallic oxides include carbon or sulfur reacting with oxygen to form an oxide. Now, non-metallic oxides are usually formed where oxygen reacts with non-metal, such as carbon or sulfur. Let's check here. Non-metallic oxide. Let's dive in. So, non-metallic oxides include elements such as carbon dioxide. Sorry, I just wait. Go. Yeah, can't see it. So basically, this is non-metallic oxides.